Hey guys, my name is Reno, and today I'm going to be teaching you about proofs with perpendicular lines. Alright, so first off, finding the distance from a point to a line. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. As you can see here, we have our point A and our line K. The distance is going to be the length of segment AB, and that's going to give us the distance from point A to line K. Alright, let's use what we just learned, and let's use that to find the distance from point A to line BD. Pause the video, try this out, and then come back for the right answer. Alright, so now that you're back, we can find the answer to this by calculating the distance of segment AC, or the length of AC. As you learned, the segment from point to the line will be the distance, so from point A to point C, that's the distance. So we can use our distance formula. AC is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug in our values. So that gives us AC is equal to the square root of negative 3 minus 1 squared plus 3 minus negative 1 squared. And then now when we plug in our values and then simplify them, AC is equal to the square root of negative 4 squared plus 4 squared. And then when we simplify both of these by squaring them, we get AC is equal to the square root of 16 plus 16. And then simplify that even more by adding them up. AC is equal to the square root of 32. And then when we take the square root of that, that gives us AC is equal to 5.7 units. So the distance from point A to line BD, or segment BD, will be 5.7 units. Alright, so now, the linear pair perpendicular theorem. So, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. As you can see here, these two angles are congruent. So, as you know that, since the linear pair creates a pair of congruent angles, lines G and H are perpendicular. Alright, the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. As you can see here, lines H and K are parallel, and as you can see here, line J is perpendicular to line H. Since lines H and K are parallel, J is also going to be perpendicular with line K. Alright, the lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. As you can see here, line M and N are both perpendicular to line P, so therefore lines M and N are parallel. Alright, so proving the perpendicular transversal theorem. Use the diagram to prove the perpendicular transversal theorem. Alright, so now that you're back, so the answer. We're given that H and K are parallel, and J is perpendicular with H. As you can see here, this symbol marks that lines H and K are parallel, and this perpendicular symbol tells us that line J is perpendicular with line H. We have to prove that line J is perpendicular with line K. So let's write a proof for this. We have our statements and our reasons. We are given that H is parallel with K and J is perpendicular with H. That's our given. So now, we know that angle 2 is 90 degrees. That's the definition of perpendicular lines. Angle 2 is congruent to angle 6. That's the corresponding angles theorem. Since the transversal is cutting through two parallel lines, the corresponding angles are going to be congruent. So angle 2 is equal to angle 6. That's the definition of congruent angles. And then angle 6 is equal to 90 degrees. That's our transitive property of equality. And then J is perpendicular to K. That's the definition of perpendicular lines. Since you know that angle 6, the angle of the perpendicular lines, is 90 degrees, therefore, line J is perpendicular with line K. I hope you guys enjoyed this video. If you found this video educational, like, subscribe, and come back for more educational videos like this.